All right. Here I will present a quick method how to transfer a high school physics course into a web-based system. It was previously a campus-based course. And we were two teachers working on this, me, Magnus Hummelgård, and my colleague Jonas Nyström. And if we go right on the results. The results is that more than half of the students improved their grades. That was the result compared to the campus-based version. So just to give you a general background, this is a high school physics course. It's about the later part of the physics they are supposed to learn at that level. So it's basic wave mechanics, some introduction to quantum mechanics. It's some electromagnetic theory. It was supposed to be given at 2 campuses. It is a total of 55 students. And this was already set and prepared with schedules and everything to be sort of general lectures and so on. But due to these Corona times, we needed to sort of quickly have an efficient method to just transfer it over to the web as fast as possible, because we didn't have any sort of preparation time for it. So the concept was we take the Zoom web-based conference system, the thing that I'm talking into now, that system can handle 2 cameras actually. It has this document camera feature, but that function actually only looks for another secondary USB camera connected to your computer. So if you have 2 web cameras, you can use the other camera exactly as I showed you just before here, as a notepad device to write, show equations, write theory or general text, or just show from the course book and so on. So it functions like the regular whiteboard that you use when you're lecturing. So that gave me as a teacher a very sort of quick way to adapt into this new environment. And if I show you just around a little bit, you can see this is two cameras. One is the thing that's filming me, the regular web camera. The other one is filming this notepad. The notepad is fixated. You see, it's a classic springboard here that you have fixed just blank sheets on. It's taped to the desk, so it is at the same position always as you see the camera above here, located on a tripod stand. This camera is a Logitech C922. It must be a HD camera, otherwise the resolutions will be too poorly for the students to see what you actually are writing. So if you need to prioritize, you can sort of have the bad camera, so to say, can be the one that's filming you, because that you don't need any resolution for. You must sort of have good resolution on the notepad. So and the HD is sort of the lower end there. So that's what we did. We had we uses the Moodle web platform also for communication and for all materials and everything. I gave lectures like this in the Zoom. It's in the same way as I'm doing now. And we also recorded all lectures. So after these sessions, they were put up on the web so students could watch them afterwards as well. When it comes to physics, you also have laboratory classes, practical sessions that they're supposed to do. In this course, it is 5 laboratory sessions of 2 hours each that the students need to do. That we needed to transfer over to the web as well. The laboratory exercises in this level is very sort of simple stuff. So we decided to make filming the experiments short movies, 5 minutes, where the operator doing the experiments. And then the students are supposed to do quizzes around this. So the students start with a pre-quiz, where they sort of is tested if they have the sort of required knowledge to understand what's going on in the experiment that they are going to see. And then they see the experiment, and then they are sort of doing a quiz that is more in-depth. And it can be around 15 to 30 questions where they do calculations and so on. That's the links to the experiment. So I will show you that now. So it looks like this. You see here, this is the first lab session they're going to do. There is a quiz. And if you look on the quiz, so you see this is the pre-quiz. It's 5 questions. So 4 of them are theoretical. And I can show you one of the theoretical questions. Looks like this. So here, the first laboratory session is about wave mechanics. So this is standing waves on strings. So you see here, they get 2 situations of standing waves, and they're supposed to mark out where all the nodes is in these 2 figures, and so on, just to sort of test the student if they know the concept around standing waves. So, and the next question in the pre-quiz, you can see here, they are giving a sketch about the experimental equipment in the movie. And then they see a frame dump from the movie showing the real stuff. So here they're supposed to mark out the key parts of the experiment. So you can see there's some weight that makes some tension in the string here. They're supposed to mark out that. Here is the vibrator that makes the standing waves on the string. It's a signal generator and so on. So then they know what to look for in the movie. So after they've done these things, they come to the movie session. I will show you that. This is the movie session. So here you can see the same thing as the picture you saw before, but now it's a movie, and you can see the operator is turning the frequency in the signal generator, and it arranges different types of standing waves. And the students are supposed to do both read the values of the frequency, but also they are giving some lengths. You can see in the beginning of the movie here you see they can measure the length of the wire and so on. These movies are around 5 minutes, so very short and compact movies about the experiment. And when they've done that, they continue over to do the actual calculations regarding these experiments. It looks like this. So here in this first lab session, it was 16 questions it's supposed to go through. And there are all kind of different questions, and the most, for example, they can calculate, we can take one question here. Here you see one question. Here is the velocity of the wave on the string, and you see it's given by this equation here. And then they're supposed to calculate that by measuring the force in the string. It comes from the weight, right? And then they write the answer here, and it's automatically corrected if you can do the right calculations. And they're also supposed to choose a unit also. So that's the laboratory sessions that we made. So we transferred all these five regular laboratory sessions into the web in this way. And then that seems to be worked out well. And we also tried to add some gamification theory. That was a very, very quick and dirty thing we tried. Lack of time, we didn't manage to do so much about it. But at least we made one badge hunt thing. So the students were giving a sort of a test called the Newton's challenge, where they supposed to answer, I think it was 8 questions within a certain time limit. If they pass that, they get this sort of little digital sticker. It was a picture of the Newton's apple, right? And it was a very, very hard limit on it. So they really needed to practice to reach that. They can try as many times they like. And most of the people students tried several times on it. And it was quite tough. So only 10% passed it. So, but the idea is to add this gamification factor to this web-based course to make the students sort of more encourage the students to perform better on the course. So that was the sort of the things that we sort of added. We used the Zoom conference system. We transferred the laboratory sessions over to the web. We tried to add some gamification, but that was very slim. So what was the result of this? Go to the result. Take my second camera here. Well, the result was, you can see here, one can use also pre-made slides, right? The results were that we managed to do 20 lectures. The whole course is 20 lectures in 90 minutes each. All that was put online. It was filmed in this Zoom web conference system. So it's accumulated to movie time and goes up to 30 hours online. If you look at statistics, 334 hours viewing time were made by all the students together until the first exam. The course was conducted during April and May, you can say, over 2 months. And after the first exam, another 24 hours of watching occurred, which is sort of a positive value compared to a campus-based system, because then you don't have any more teaching after the first exam. The 5 online laboratory sessions that I mentioned, the students spent half hour each on the pre-quizzes, plus another 1 to 1.5 hour on this calculation quiz that they do after the movie. So the campus-based version is conducted in 2 hours, the normal way. Here we see that they spend almost the same time. These are the median values of the population. So it's around the same kind of effort by the student. We believed first that perhaps it was a little bit sort of too lightweight to make the laboratory sessions in this way. But it actually turned out to be pretty, be enough for the students, so to say, to handle it. If you look at the performance in the exams, you can see that 42 students out of 44 who made the first exam passed. That was a very amazing result. That means 95% passed the first exam. 1 week later, they have a re-exam, and then 9 out of 11 students passed that one also. And that gave a total result of the course to be 51 students out of 55. So 93% passed the course. And here I want to sort of emphasize that the exam were made also by a secondary teacher that were not involved at all in this course. That teacher is very experienced, made the course, conducted the course several times for many years, but he was not involved in this particular web course. So, but he made the exam, so that was some kind of blind test on this. And the students still performed 93%. That's a very good result. We also have data on one of the campuses. That's the Sundsvall campus here, where 22 students at that campus also were attending a previous course in physics, so that I conducted before Christmas. So then we could sort of correlate the data between how did they perform on that course, which was conducted in a regular campus-based way. So we could compare that to what is the effect of transferring this course into a web-based course. So the physics is sort of in this campus is given in sort of two following courses. So there's course 1 and course 2. So the second course were the one that I'm talking about here, that is completely web-based. So then we could compare one by one, student comparison, how the performance was in a campus-based system versus this web-based system. And if we look on the result, you can see that one student actually got a lower grade than before, but 6 students out of 22, they had the same grade as before, so they were not sort of affected. But 7 students raised the grade by 1 step. That means if they have a C, they got a B. If they have a B, they got an A, and so on. And 8 students raised the grade by 2 steps. That means if you have a C, you get an A. And that was very impressive. So if you combine these two, you see more than half of the students actually improve the grade, which is very, very good result, I would say. And we can also go and look. There's a poll afterwards. The course is conducted, anonymous poll, about what they sort of in general experience of the course, what they think the quality was, and so on. I can show you that. No. Here, right? So this is the evaluation report by the students. It's not everybody has answered yet. It's very early. So 8 out of 26 students have answered. So if you look at the result here, basically, I will not talk so much about it. If it's to the right part here of the scale, that means they have a sort of a general good impression about it. If it's down to the left here, that means they think it's horrible. And you can see it's, if you look, what is the general opinion about the course? Is it bad or is it very good? And then, so you see, it's most of the students in these 8 that also these 8 that replied thinks it's quite good. And there's several questions. You see they go down the list here, and it's you can see it's overall general very positive answers by the student. And that is very, very good response from the students. But we also added some extra questions regarding the web-based concept. So this first one here, like this one says, how is your experience or interpretation of the situation if now when it is a web-based system compared to a regular campus-based version? And you see it's overall positive. And then it asks, have your motivation to study improved or decreased? And they say that has improved due to the web-based system. And then you can see, if you compare the web-based teaching to the campus-based teaching, do you believe that you have learned more due to this web-based system? And they seem to believe that also. And the fourth question is, the laboratory sessions also conducted over web. Do you believe that it was you learned more due to that effect, or do you learn less? And you see it's a little bit sort of more spread out there, but slightly positive. And the final question regarding web-based system is that how much time did you do you believe you spent on, okay, I say it, how much time have you put into the course compared to if it would have been a regular campus-based course? I mean, basically, do you have worked more because it was a web-based system or less? And they say they have been working more. From a teacher perspective, that's sort of good. From student perspective, I don't know. And here is just a profile of the above questions. You see if it's further to right, the more positive the students are. So it seems to be very, very good response from the students as well. So we're sort of surprised by that. It was a challenging task for us as teachers as well. So it's overall positive results. If I made some discussion about the overall discussion about the topic, I would say that transferring in the laboratory sessions took longer time than we expected. The main reason is that making online quizzes takes a lot of time. You know, from our experience now, we can say that for each 1 hour laboratory session, it takes 5 hours to make the corresponding quizzes to it. To film and make the movie about the laboratory session, that takes 2 hours per each hour of laboratory session. So that means for a 2-hour laboratory session, it will take 4 hours of movie and 10 hours of quiz making, corresponding to 14 hours of work time to transfer the laboratory 2-hour session to the web. I would say that the best thing with this was this dual web camera system. It was super easy to get start going. It's very natural for you as a teacher to write just on regular papers. You can prepare, you can show pictures from book or whatever, in all the ways you're sort of used to work in a regular classroom. It was some glitches about, for example, this automated functions of focus and brightness of the camera and so on. That was a little bit tricky to set up. But when you pass that, everything runs smoothly from there. For the students to have a possibility to watch the content offline, so to say, after the live seminar, that I think has a positive effect. We can see in the data that the students that are lagging behind, we can see and follow them about when they're watching the lectures in the chronological order. So we could, for example, see that 1/3 of the student group was 1/3 behind in this in the amount of in the subjects of the course. So overall, I think it was a positive experience for our teachers. It's a little bit challenging, but overall positive. And the result was that more than half the students actually improved the grades compared to the previous course, which was a very good result. That's it. Quick summary of how to transfer a high school physics course into a web-based system.